nines. Back again. I've got a request for number 7 on page 343, so I thought I'd just take you through that. So if we take a quick look at the question, it says workers at a lab get the same raise each year. Colette, who has been working at the lab for 5 years, earns $17.25 an hour, and Lee, who's been working at the lab for 1 year, earns $14.25 an hour. The equation relating wage and number of years worked is of the form W equals MN plus B, where W is the hourly wage, so that's your Y, and N is the number of years worked. So because we know they get the same raise each year, we know that the slope is going to represent the raise that they get every year. So the first question says you have 2 points, 5 and 17.25, and 1 and 14.25, and explain why these 2 points are on the line. So if we take a look at what we've been told, well, we have been told that that this equation represents, okay, the wage and the number of years worked. And we've been told that Colette has worked at the lab for 5 years and she earns $17.25 an hour. So we know that after 5 years, Colette earns $17.25 an hour. Or sorry, earns $17.25 an hour. And we know, so that means that since she earns $17.25 an hour after 5 years, at that point has to be on the line if the line relates how much they earn to the number of years they've worked. And then we also know that Lee has worked for 1 year, earns $14.25 an hour. So after 1 year, we know that Lee earns $14.25 an hour, and so both of those points then are on the line that's going to be represented by this equation. Okay, so if we move on to B says find the slope and the W-intercept of this line and explain what they mean. So the slope is fairly straightforward. We have 2 points, right? We have our number of years, and we have our wage, and we have our number of years, and we have our wage. So we can use the slope formula to calculate the slope. So we know that slope is equal to, again, the difference in the y's over the difference in the x's. And so even though we're representing this by n and this by w, in any coordinate pair, no matter what letters you're using, right, the first is the x and the second is the y. So if I make this the, it doesn't really matter, but this the first set of coordinates and this the second set of coordinates, then I can do 14.25 over 1, and then if this is the first set of coordinates, it's going to be 17.25 and 5. So when I do 14.25 minus 17.25, I'm going to get -3. And when I do 1 minus 5, I'm going to get -4. So my slope is equal to 3/4, or it's equal to 75 cents. So she's getting a raise of 75, or they're both getting raises of 75 cents each year. Okay, so to calculate, oh my gosh, I did all that without showing you any of the work. Sorry, so let's just take a quick look at that then. So I subtracted the y's and I subtracted the x's. I did 14.25 minus 17.25, so 14.25 minus 17.25 over 1 minus 5, so 1 minus 5. When I did the math, I got -3 over -4. 2 negatives make a positive, so positive 3/4, which in this case is 75 cents. 75 cents is my raise. If you look at the y's, right, the y's are being, the units for the y's is dollars is dollars per hour, and the unit for the x is years. So in this case, if I actually wrote my units here, it's going to be 75 cents per hour, right? So an increase of 75 cents per hour per year. So what the slope is then telling you then is that the wage, right? The wage, and it's positive, so the wage increases by 75 cents per hour each year. So the next thing we want to do is we want to figure out the y-intercept. So now that I know my slope, I can plug it into my equation for a line. So y equals mx plus b. All right. So I have, if you go back up here, I have an x and a y, and I have an x and a y, and I can use either of them. So I'm going to use this point because the numbers are just smaller. So in this case, this is my x, and this is my y. So I know that x is equal to 1. I know that y is equal to $14.25, and I know that m is equal to 3/4. So I'm going to replace all of my variables with the numbers that I have. So y is 14.25, m is 3/4. Because it's a fraction, I'm putting it in brackets, times x, which is 1, and because it's a multiplication, I'm going to put that in brackets, plus b. So I know that 14.25 is equal to, and in this case actually, because this is being expressed in decimals, I could easily express this in decimals. So I'm going to actually change that to 0.75 times 1 plus b. So now I have 14.25 is equal to 0.75 plus b, and so now I just need to solve this equation. So I'm going to subtract 75 cents, and I'm going to subtract 75 cents, and so now I have $13.50 is equal to b. So my equation is going to be y equals 0.75x plus 1350. And so this is the equation that represents their wage. Now, before, I think that was actually, yeah, that was actually C. So C, sorry, was this equation that you had to write. Just to finish up part B, it says, what is the y-intercept? Well, your y-intercept is always your starting amount. It's always when your x is equal to 0. Well, x represents the number of years. So in this case then, the y-intercept is how much you make when, on the very first day you start working. Okay, so so 1350 is the starting salary or starting wage. So it's how much you make on your very first day. Okay. So it is how much you make when you are first hired. It is how much you make when you are first hired. All right, so that's A, B, and C, and so D says that Maria has been working at the lab for 7 years and determine her hourly wage. So for part D, right, she's been working for 7 years, and we need to figure out her hourly wage. Well, we know that y equals 0.75x plus 1350. And so we know x is how long she's been working for, and y is her wage. So if y is the wage and X is the number of years worked. And in this case, when we read the question, it says that Maria has been working at the lab for 7 years. So that means that the variable that we're going to replace has to be X. So X is equal to 7 years. So I'm just going to plug that into this equation. So I have 0.75 times 7 plus 1350. Okay, so I'm just going to, I've got 0.75 times 7 plus 1350 equals $18.75. So after, per hour. So $18.75 per hour. So after 7 years, she'll be making $18.75 per hour. And then E says, what wage does this linear model predict for a worker who has been working for the lab for 25 years? And does this seem reasonable? And explain how the store might modify the raise policy. So in this case then, it's 25 years. So again, we know that Y is wage and X is the number of years worked. So in this case then, we know that X has to equal 25 years. Okay, so if Y equals 0.75 times 25 plus 1350. So I'm going to grab my calculator again. I've got 0.75 times 25 plus 1350 is equal to $32.25 an hour. Whoops, $32.25 an hour. And so the question says, does this seem reasonable? And then how might the store modify the raise policy? So often what you find is, in this case, if somebody's been working for 25 years, they're earning significantly more than somebody who's been working for 7 years or somebody who's just been starting out. And so it probably doesn't make sense that you're going to get a 75-cent raise every single year unless there's a lot of inflation. So they probably will set up a system where they might cap out the raises after a certain amount of time. So maybe for the first 10 years you get a raise and then you're kind of stuck at the maximum. That's often what employers do. I know as a teacher, I got raises every year for my first 10 years of service, and now that's it, no more raises. So that will often be how things are handled in the business world. As you get experience, and as your experience grows, then as you continue to get experience, and I guess they feel that you're just becoming a more efficient employee, you get paid more. But then after a certain amount of time, there's really no advantage to you working 35 years potentially to working 10 years. So you hit the cap of what you're actually able to earn. Hope that helps.